This is 8.2, the inverse trig functions continued. So we're going to start off this section with looking at composite functions, but this time around the composite functions, the inside and outside function, are not going to be the same. So if we look at this first example, it says find the exact value of the expression. The inside function is inverse sine of 1/2, and the outside function is cosine. So when you do these, you always start with the inside function. Okay, so we're going to look at just inverse sine of 1/2. So once again, if you're dealing with an inverse function, the first question you ask is the value, or is 1/2 in the domain of inverse sine in this case? And the answer is yes, because the domain of inverse sine is -1 to 1. So we're okay there. So I'm going to go ahead and move on. Next, we're going to ask ourselves, and I'm going to continue this right over here. So that's step 1. Step 2, we're going to actually evaluate this. So when you're dealing with inverse functions, you're asking what angle goes with that value. So I'm going to rely on a triangle. Now the reason why I'm drawing out the 30, 60, 90 triangle is because this is the only triangle that has a 1 and a 2 in it. The other triangle we know is 45, 45, 90. Remember, that's radical 2 on the sides, and then the hypotenuse is 2. So that doesn't work. Sine. Sine is defined as opposite over hypotenuse. So what I'm going to do here is I'm going to highlight the sides that are 1 and 2. And now I'm going to figure out what angle will give me the correct values. Remember, I'm looking for side opposite to be 1 and the hypotenuse to be 2. So when I look at this, it's 30 degrees because the side across from it, or opposite of it, is 1 and the hypotenuse is 2. So I've just evaluated the inside function, and I have this down to 30 degrees. So the inside function is 30 degrees. Next, I have to look at the outside function. So the outside function is cosine. So now I'm actually looking for cosine of 30 degrees. So once again, you could have this memorized. You could rely upon drawing the triangle out, or you could rely on that unit circle. So if you're going to rely on the unit circle, just find 30 degrees, look up the cosine value. So remember, cosine, if you're using a triangle, is adjacent over hypotenuse. So the adjacent side to 30 degrees is radical 3, and the hypotenuse is 2. So the answer to this is going to be radical 3 over 2. All right, let's work on the next one. So the next one says find the exact value of the expression, and the inside function this time around is inverse tangent of negative radical 3. So once again, our first question is, we're working on the inside function, and we're seeing if negative radical 3 is in the domain of inverse tangent. And the answer is yes, because the domain of inverse tangent is -infinity to +infinity. So we're okay there, so we move on to step 2. Step 2 is to evaluate the inside function. So I'm actually taking inverse tangent of negative radical 3. And I'm going to write this as negative radical 3 over 1. And the reason why I'm doing that is because, remember, I need two sides, because tangent is defined as opposite over adjacent. So once again, I'm going to use a 30, 60, 90 triangle, and the reason I'm doing that is because the 30, 60, 90 triangle has radical 3 and 1 as its sides. So I'm going to go ahead and highlight radical 3 and radical 1. Now I'm looking for an angle that gives me the opposite side as being radical 3 and the adjacent side as being 1. And I see that 60 degrees does that. So I have 60 degrees, but remember I had a negative. I'm taking inverse tangent of negative radical 3. So this will require me to know the domain and the range. So the range of inverse tangent is going to be, my y value has to be a value between negative pi over 2 and positive pi over 2. So negative 60 degrees is going to be the answer because it's in the range. Okay, your range for tangent is quadrant 1 and quadrant 4, where positive values go in quadrant 1 and negative values go in quadrant 4. So now I have the inside function evaluated as negative 60 degrees. So my last step is to work my way to the outside function. Okay, so the outside function in this case is sine. So I'm actually taking sine of negative 60 degrees. If you remember, I can have negative values with all the inverse functions, but I can't have negative values inside parentheses with regular sine, cosine, tangent, etc. So because I have a negative value inside the parentheses, I have to apply the even-odd rules. So the even-odd properties say that sine is odd, meaning that the negative sign comes out, so I have to evaluate negative sine of positive 60 degrees. So once again, you might have this memorized, or you're going to use the unit circle, or you use the 30, 60, 90 triangle, and know the fact that sine is opposite over hypotenuse. So I'm looking at 60 degrees here, and opposite over hypotenuse will give me radical 3 over 2. I'm going to bring down the negative sign out front to get negative radical 3 over 2 as my answer. Objective 2. Objective 2 goes over how to find the inverse functions of the other trig functions. So if we look at the first one, it's dealing with secant. Remember that secant is the reciprocal function of cosine. So we're going to talk about that relationship in a second. So the domain of inverse secant, and if you remember the graph of inverse secant, it had things that look like parabolas shooting up or down. The domain is everything that has to be greater than or equal to 1. So the absolute value of x has to be greater than or equal to 1. The range. The range is any value between 0 and pi, excluding pi over 2, because inverse secant is not defined at that point. So the range is quadrant 1 and quadrant 2. So if your values are positive, they're going to go in quadrant 1. If your value is negative, you will have an angle that's in quadrant 2. Okay, let's look at the next one, which is inverse cosecant. So the domain for inverse cosecant is the same thing as inverse secant. It's the absolute value of x has to be greater than or equal to 1. And the range is from negative pi over 2 to pi over 2, with the exclusion of where y equals 0. This is going to give me quadrant 4 and quadrant 1. So if you're looking for an angle with inverse cosecant, if it's negative, it's going to go in quadrant 4. If it's positive, it's going to go into quadrant 1. And then we're going to deal with cotangent. Cotangent's domain is all real numbers, so that's kind of nice because you don't have to check them. And then its range is the value from 0 to pi. So that's quadrant 1 and quadrant 2. So if you're looking for an angle that's positive, it's going to go in, or if the value is positive, the angle will be in quadrant 1. If the value is negative, then the angle will be in quadrant 2. So let's make a little chart quickly. So the three trig functions are sine, cosine, and tangent. Okay, so we're looking at, remember, the inverse functions. And then the reciprocal of each one, the reciprocal of sine is cosecant. So let's look at inverse cosecant. The reciprocal of cosine is secant. So let's look at inverse secant. And then the reciprocal of tangent is cotangent, inverse. Okay, so I'm dealing with just the range. So the range for inverse sine is negative pi over 2 to pi over 2. So if your value is negative, you want a quadrant 4 angle. If your value is positive, you want a quadrant 1 angle. So for inverse cosecant, it's the same, right? Just look up here, and you'll see it's the same thing. But there is one restriction. So the restriction is that y cannot equal 0, okay? But if you have a negative value, you're going to be in quadrant 4, and if it's a positive value, your angle is going to be in quadrant 1. So that's the same, okay? So there's one little catch with that. Let's look at cosine. The range for cosine is from 0 to pi. So that's quadrant 1 and quadrant 2. So if you have a positive value, you're going to have an angle in quadrant 1. If you have a negative value, you're going to be in quadrant 2. Secant, the range is the same. So it's from 0 to pi, but there's a catch that y can't equal pi over 2. So that's a place where it's undefined. So once again, in quadrant 1, you're going to have a positive. If you have a positive value, you end up with an angle in quadrant 1. If you have a negative value, you're going to have an angle in quadrant 2. And tangent, the range for this is from negative pi over 2 to positive pi over 2. That gives me a quadrant 4 and a quadrant 1 angle. So if you have a negative value, end up in quadrant 4. And if you have a positive value, you're going to have quadrant 1. Cotangent's different. So these are ones that are different. It's 0 to pi. So you have quadrant 1 and quadrant 2. If it's positive, it's going to be an angle in quadrant 1. If the value is negative, you're going to have quadrant 2. So all of them match up except for tangent and cotangent. But the nice thing about inverse tangent and inverse cotangent is that they have the same range, or same domain, excuse me, not range. The domain's negative infinity to positive infinity. So while they might not have the same range, they do have the same domain. Alright, so let's go down and see what we have here. Find the exact value of cosecant inverse of 2. So first question is 2 in the domain. So the domain of inverse cosecant is the absolute value of the value has to be greater than or equal to 1. So since 2 is greater than or equal to 1, yes, we're okay. So first check is okay. And now we have to actually evaluate. So we'll call this step 2. That's going to be step 1. So we're going to evaluate cosecant inverse of the value of 2 over 1. So once again, I'm writing this up because I have to rely upon the triangles. Alright, so the triangle is 30, 60, 90. 1, 2, radical 3. I'm going to go ahead and highlight 2 and 1. And remember, cosecant is the reciprocal function of sine. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. Okay, so if we just flip that over. Okay, so the hypotenuse, I want that to be 2, and I want the opposite side to be 1. And the angle that will give me that is 30 degrees. So the answer is 30 degrees or pi over 6. Let's look at the second one. Find the exact value of the expression inverse secant of negative 2. So once again, I'm going to rewrite this as negative 2 over 1. First question is negative 2 in the domain. So the domain of inverse secant is the absolute value of x has to be greater than or equal to 1. So if I take the absolute value of negative 2, is that greater than or equal to 1? The answer is yes, because the absolute value of 2 is 2. The absolute value of negative 2 is 2 is what I meant to say. So this is okay. So I move on to step 2, evaluate inverse secant of negative 2 over 1. So once again, I'm going to ignore the negative just for the time being, and I'm going to use the 30, 60, 90 triangle. And the reason why I'm doing this again is because this is the only triangle that has 1 and 2 as one of its sides. Secant is the reciprocal function of cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. So I want my hypotenuse side to be 2 and my adjacent side to be 1. So I'm going to go ahead and highlight these, and the angle that will give me that is 60 degrees. So I'm going to let that set for a moment. And before I state what the answer is, I have to know the range. So the range of inverse secant is from 0 to pi, and we have a problem spot at pi over 2. Okay, so once again in quadrant 1, if my value is positive, I'm going to look there. But remember, our value is negative, so I need to have a quadrant 2 value. So I have to move 60 degrees to quadrant 2. And to do that, I take 180 degrees and I subtract off 60, which gives me 120 degrees. And this is my answer. Alright, so that's it for part 1. You're going to have a second part that will talk about the use of a calculator to approximate each expression. So be on the lookout